Alright, so for the bell ringer, go ahead and take a second and solve 1, 2, 3, and 4 using substitution like we did in our homework. So go ahead, take a minute and use substitution to work on the bell ringer. I'm going to walk around and see how we are doing. So again, in number 1, what's nice about number 1 is they already gave you the x value. So you were just directly substituting that 4 into the equation. So they already gave you the x. All you had to do was plug it in and solve for y. Remember that these represent ordered pairs or solutions, so that they are going to give you a point of intersection along a line. Either go to the nurse or wake up. If you're to sleep while I'm teaching and your classmates are learning. Either wake up or go to the nurse. That was nice the first time. If you have a case like yesterday, where they do not intersect, then there's questions, comments on 1 and 2. So I know like 1 kind of threw us off because it didn't have the expression. That's going to be next. Just watch our signs. I did when I walked around. I saw a lot of negative 9s. So just be really careful of your sign. It means you lost a negative somewhere. So if you had a negative 9, you lost your negative somewhere. Okay. Let's do 3 and 4. So in number 3, I would solve for y, because that is going to give me an easier expression to look at. So you have y equals 5 minus 2x. I'm going to replace the y in the second equation. So I have 3x minus 3 times 5 minus 2x equals 3. Distribute that negative 3. I'm too close to the edge. Minus 15 plus 6x equals 3. Add 15 to both sides and combine like terms. So 3x and 6x gives you 9x, and that's positive because it's a negative times a negative. A positive 3 and a positive 15 give you 18. 18 divided by 9 gave x equals 2. We take that 2, plug it back in for y. So we get 5 minus 4. And we see that y is equal to 1. In number 4, I'm going to solve for x in the bottom equation, because I can simply add 2y to the other side. Then I'm going to replace x in the top equation with 2y. So again, you're never replacing from the equation you solved from. So I can't put 2y in here, because then I just get 2y minus 2y, which is 0, and that doesn't help me solve for y. So you always have to plug it into the opposite equation. So now you have 2 times 2y plus 2y equals 4, or 4y plus 2y equals 4. So 6y equals 4, or y equals 4 over 6, which is 2/3. That example, or that problem, is an example of why we don't change it to a decimal. Because if I change that to a I'm going to specify substitution or elimination. So you have to know how to do both. So I'll have like 2 substitutions, 2 eliminations, and like maybe 6 where you can pick which one you want to use. And we're going to talk today and tomorrow about when it's better to pick one versus the other. So for substitution, we already discussed the best time to pick substitution is when you have a variable with a coefficient of 1, because you can easily solve for it. With elimination, what I'm looking for is for additive inverses, meaning that when I add the equations together, I have opposites. So in this example right here, 3x and negative 3x are additive inverses. When you add 3x and negative 3x together, what do you get? 0. So what we're going to do for elimination is add the 2 equations together and eliminate a variable. So 3x minus 3x is y minus 2y is negative 1y. Negative 9 plus 12 is, can we have negative y equals 3? So what do? So y is equal to, perfect. Now again, just getting one variable is not enough. I have to also then go find x. So what we're going to do is take that negative 3 and plug it in to either equation. So you have 3x minus 3 equals negative 9. Add 3 to both sides. We get negative 6. Divide by 3. And x is negative 2. Yes.
For 3x minus 3x,
Yes, but I didn't subtract, I added. So like in the...
That's an
Yes. My board was very close to glitching out on me, so like I was like, it was trying to like take me to my home screen. So yeah, that's what I'm not gonna do it on there. This is a like why? Like what is it doing? A plus sign. All right. In example 7, if I add those two equations, is a variable going to cancel? Yeah. So let's add them together. 3x plus 2x is negative 2y plus 2y is 14 plus 6. 5x equals 20. Therefore, x equals... Okay. If I have x, I still need... So I take that x equals 4 and I...
Plug it into either.
Yep, so if you plug it into the bottom equation, it's all addition. If you plug it into the top equation, you have subtraction. Not that it truly matters, but if you take 2 times 4 plus 2y equals 6, 2 times 4 is 8. So then you have 8 plus 2y equals 6, so you subtract 8 from both sides. 2y equals, good, divide both sides by 2, and y equals, excellent. So, Will, this kind of gets to what you asked me. Instead of adding them, I want to subtract in this problem because that would give me 4x minus 4x. So sometimes we add the equations, sometimes we subtract. Just make sure when you subtract, you make sure you subtract every part. Exactly. Because it's 4x minus 4x, which is 0. But it's 9y minus 6y, which is not 15y. Like you don't add the 9 and the 6, you're subtracting them. See? And then it's 1 minus a minus 2, which is really like 1 plus 2, which is really... So y equals positive 1. Yeah, because I think x is... Okay, so now take that positive 1 and plug it back in anywhere you want. Yeah, unfortunately, we don't stay on it much more than a week. And then the 9 weeks. All right. Next two set of questions. See, you like it, but I feel like you kind of like it prematurely because all those first three examples are super nice. What happens when the examples are not so nice? So you have to now multiply the equations so that one of the variables cancels out. So we want to make the m's cancel.
Get times the top one by 3 and the bottom one by 2. I remember.
Yep. So we're going to multiply the top one by 3. The whole thing.
No, this is still.
So 2 times 3 is? 3 times 4 is? And then negative 4 times 3. Now, to make your life easy, if you multiply the bottom by negative 2, you don't have to subtract the equations. You can add them, and the m's will cancel. So I would multiply my bottom by negative 2, so that I get negative 6m, negative 10n, and positive 6, because now I can just add them together, and the m's cancel. You get 2n equals negative 6, and n equals negative 3. Plug n equals back in to the originals, because the numbers will be smaller. So 2m minus 3 times 4, which is 12, equals negative 4. And you get m equals 4. No.
No, it's just like one extra step.
So in number 10, do you want to eliminate x or eliminate y? Doesn't matter. You just have to pick which one you're canceling. So let's say I eliminate y. We'll multiply by 2. So you have 6x plus 14y equals 30. So in order to eliminate y, I need the bottom to be negative 14. Perfect. So negative 5. Yep. So negative 35. Negative 14y. Positive 28. So 35 take away 6 gives you 29, but it's negative because the 35 was negative. 30 and 28 is 58. And nicely enough, 58 divided by negative 29 is negative 2. Take that negative 2, plug it back in. So you have 3 times negative 2, which is negative 6, plus 7y equals 15. Add 6 to both y sides. 7y equals 21. Divide by 7, and y equals 3. Yes.
It doesn't matter what you multiply by as long as they match.
Correct.
You don't have to multiply the top equation by 5 like you did with the other.
No, you could.
It could be anything as long as they match up.
Yep. Okay, in number 11, what could I only have to multiply one equation. Which one? Yeah, because if I multiply the top one by, does. So what is that? What's that going to do to my problem if they all cancel? Or, yeah, so it's going to depend on what they cancel to be. So if you multiply the top by 2, you get 0 plus 0 equals 12. Does 0 equal 12? So what's that tell you about these lines? They were parallel. You do? All right. Well, because we're running short on time, I'm just going to leave it up. You only have to do the next example. You can cross out 13, 14. In 12, if you multiply the top one by 2, that's what I was saying. You have to be careful because this time I get 0 equals 0, which is true. Therefore, instead of no solution, they're infinite solutions because instead of being parallel lines, when you graph them, it's, yeah, because it's one line.